Hello, everyone. My name is Chris Battisto, and welcome to the March 12th, 2026 ESIP Information Technology and Interoperability series. Joining us today is Jorge Bravo. He is an atmospheric scientist with more than a decade of experience in weather modeling, remote sensing, and scientific programming, with a strong focus on applied research and operational implementation. He's currently a PhD student in civil engineering at the Stevens Institute of Technology. He's conducting research on improving weather models over the New York City area and advancing their practical applications. Today, he'll be presenting the MPAS-Viewer tool, which is an open source tool that he's been working on. We're going to have about 30 to 45 minutes for the lecture portion, with any remaining time for any Q&A. You can put your questions in the chat, and then we'll go ahead and call on them in order. Or once Jorge is ready for questions, we'll go ahead and have you raise your hand. This meeting is being recorded, and it will be later posted to the ESIP IT&I YouTube page. So with that being said, Jorge, I will go ahead and hand over to you. Thanks for joining us.
Thank you, Chris. I really appreciate your invitation for participate on this webinar. And now I will share with you all my screen. Okay, great. Are you looking my screen, right?
I am, yes.
Okay, perfect. Well, as Vincent mentioned, my presentation is called MPAS-Viewer. It's a visualization for MPAS data and on its unstructured native data. So first, I will introduce myself. My name is Jorge Humberto Bravo Mendez. Jorge Bravo is fine. And I'm PhD student at the Stevens Institute of Technology. It is located in Hoboken, New Jersey. Basically, is the New York metropolitan area. Based on that, I will start speaking about my research. What I start here when I start my PhD is to use Word. So, but first, most of you know, New York City, New York metropolitan area, is one of the most populated cities here in the US, and it also is the most diverse and the most influential American metropolis here in the country. This area is affected by different weather systems, high latitude and tropical latitude. So some cases we have a combination of both. So for these cases, to identify these patterns, global weathers are really good, right? You can identify for the movement of these big systems. But what happens when you need this high resolution for urban or local areas? So in my research, as I mentioned before, my first goal was to improve work, the most used globally weather model, right? But after that, we decide to start to use MPAS. Well, I will speak about more about MPAS later. Now, as study case, we started with the remnants of Hurricane Ida. As probably most of you know, this tropical cyclone impacted on on the US, and the most common is when a tropical cyclone impact inland, so it start to decrease the intensification, right? But what happened particular with Ida across the as long this crosses the US and basically crosses this Appalachian area, it continue with this force to continue the convection. And so just before to enter the New York metropolitan area, it increases also because it was under combination with a cold front. So that's why just a couple of hours just crossing the New York metropolitan area, this combination triggered and convection and a lot of rain for this area. So based on that, what we did, as I mentioned, I use Word, we use three different domains, one 9 kilometers. This is this blue line. After that, in the middle is this 3 kilometers, and the inner domain 1 kilometer for the higher resolution. Uh, our first idea was use ERA 5 reanalysis to generate different simulation scenarios. And after that, when we had these the best scenarios, the idea was to use GFS because the purpose is have uh, forecast, right? High resolution forecast for this area. Also, we consider for the evaluation use weather stations and graded based, in this case, multi-radar, multi-sensor data, almost known as MRMS data. This is an idea what we did for our combination of different scenarios. And the most changed physical parameters was the microphysics, the cloud, and the urban physics. So we generate different combination of all those physical parameters, and we get this kind of weather maps. This is accumulated. This is the MRMS, and all others are they accumulated exactly for the same period. Uh, and after we identify the best, we did exactly the same, but for GFS, considering also some scenarios that was acceptable. And also, this is a gridded based, and after that, also we did the comparison in time series basis with the weather stations. Now, how we start to think on use MPAS for this case. So, as probably most of you know, most of the weather universities, centers, most most of them are migrating from WRF to MPAS, right? So also based on that, we decide to know stay back, and we start to work on MPAS. So the first problem that we identified was, as I as you saw before, our WRF is 1 kilometer, but MPAS MPAS the high resolution mesh that you can download from the no MPAS Atmosphere website is 3 kilometers. For us, our perspective was it's not the best idea compare 1 kilometer grid of MRMS with MPAS 3 kilometers. So it is possible we can regrid, we can increase the resolution, and we have this. But if we have our 1 kilometer work, the idea is to have 1 kilometer MPAS grid, right? So that's why after certain point of find or try to search in websites, GitHub, places we identify how how we can create our own mesh here for this New York metropolitan area. So in this case, the idea was how we can replicate what we did with Word now with MPAS. So here is how we found the best way to create more or less same domain. So as you can see here in this side, we have again our first word domains. In this case, the black line is the outer domain, the blue is the middle in word, and the inner 1 kilometer is here. So now what we did is basically I took this rectangle and I identified where is exactly the center. And based on that, I create my mesh. And this red circle is the inner domain or inner high resolution inside MPAS. This part is the transition, and after that is 9 kilometers. So the idea is to have approx the same structure, 1 to 9 kilometers. But here, when we combine with it, we can see that our MPAS is smaller than Word, but for our own purposes, which is compare 1 kilometer Word with 1 kilometer MPAS, works fine. So same as before, we used different methods. One of them was use the weather station that we had, which are Masonet, New York, Masonet, New Jersey, and some of the NOAA NSA. And here you can see the different weather networks. Another idea was how we can compare here the WRF and MPAS with MRMS. WRF is relatively easy because both are gridded, rectangular gridded based, right? So here basically with a simple regridding MRMS to WRF is easy. And here you can see these square-based cells grids. But what happened with MPAS? With MPAS, as you can see here, well, here is not so obvious, but is hexagonal based the grid. What I did was try to change MRMS square grid to MPAS grid. And now here in this side, these are zoom in on these two different grids. You can see here, based on Word is a square, but based on MPAS is hexagonal gridded. So my plan in the near future is try to generate this more automatically also to convert my gridded square gridded data to MPAS data when the idea is to compare with MPAS. So another problem that we identify is how you can extract time series. Time series based on imagine do you have these weather stations, and in Word is relatively easy, right? So because there is a lot of Python libraries that you can extract exactly and grid cell based on a specific point. So if you select lat long of your weather station, you can extract time series. But for MPAS is totally different because the grid is on a structure, so you cannot say lat long and you extract because you need to identify the number ID of the hexagonal mesh. So that was another problem that we identified, but I will try to explain later this. So based on that, we identify how to do that. And here is a couple of comparisons, our MPAS and our Word. Also, I forget to mention the weather stations. Yes, here was divided. Uh, all all the stations were what are inside of the city are considered are urban, and all others are not urban. Okay, that's why here is comparison in metrics, Word and MPAS, and in non these are non-urban stations. So in this case, we identify that MPAS is working better than Word. And also I need to mention that MPAS was not modified the schemes, was used what the setting is by default, and that's it. But as you can see, is relatively good. In particularly these two that I'm enhancing with these red boxes, in my opinion, are really acceptable. But on the other hand, when we are comparing Word and MPAS with against in situ urban stations, we can identify that Word is working better. But here probably is because our target at the beginning with Word was to use specific urban urban parameters, urban schemes. Sorry. So I'm not sure if you know, but just now MPAS doesn't have these urban schemes. That's why we are considering that for these specific areas and for related with our own research, Word is working better than MPAS. Okay. Now, I think I'm speaking faster, right? Yes. Um, as I mentioned, we identify these problems. First, how we can identify the cell ID of this cell script. We know we know that there is different uh, tools that works for MPAS, but for us was not enough. We needed something else. Probably because also I'm not familiar with that tools. I try to understand to learn, but I prefer to start to develop my own uh, code. So now I will start to speak directly about this MPAS-Viewer. So as probably most of you know, commonly for our process data, we have two different kind of data, right? One is the vectors. The vectors like the GeoJSONs, like the most known probably is shapefile. It's old, but most of the people know shapefile, right? So in this case, it's really easy how to display these geographical information systems or GIS are working really well with this kind of data. Another are the raster data. Also, this raster data is really easy to use. Uh, Again, this GIS software or Python, many ways to read the data and use directly to identify values, to crop, to merge. It's really easy. But what happens when you have these irregular geometries or unstructured data? So I know that there is a couple of libraries that works fine. By the way, just now inside of QGIS, there is a library called MDAL, similar to GDAL, but MDAL, and you can integrate directly some specific irregular meshes like this. That's why, by the way, this icon I take directly from this QGIS website. You can see this is associated with vector, this is associated with raster, and this one is associated with unstructured meshes. So, well, also I'm not sure if you know, but these kind of unstructured meshes are relatively most used in hydrological purposes. I took this image from one website, but this is I'm not sure if it's HECRAS, maybe yes. Um, what else? Now, um, many other weather models have started to use these unstructured meshes, and one of them is MPAS. MPAS uh, is this new is the next generation of weather models. What I hear is NCAR is start to say, please, if you are using Word, we are recommending to you move to MPAS if your process permit. So the thing with MPAS, do you have this unstructured mesh and looks like an honeycomb? So the advantage on this is you can avoid this nested domains. So in the same mesh, you can increase the resolution. And uh, theoretically, or what I understand is uh, in the edges on the transition between domains, you are not getting these errors at the borders. So this is one advantage on this kind of models. One problem with this, as I mentioned before, is not easy. Is really not easy how to display the data. Particularly, I like a lot to work with QGIS. For me, is when I'm trying to check the metadata, the structure, how is the data of the common data like GRIP, like MCDF, like HDF. I'm using QGIS. Um, or in other cases, uh, another software that I really like to use is the Unidata IDB. But the problem, if you try once to drag and drop this QGIS MPAS data in QGIS, it will show you something, but like this image. So it's some structure because at the end of the day, MPAS the output data on MPAS is an HCDF, and HCDF is an kind of gridded based. But the problem is to understand this HCDF format, you need to know how is the structure of the centroids, the vertices, and the edges of each hexagon. So that's the most problematic part, in my opinion, to use the outputs of MPAS. So now we know that these traditional tools are not uh, easy to use or are not are unable to use MPAS, right? But I know that exists a couple of specific libraries in which you can read directly MPAS data. One of them is called ParaView. Once I try to learn to use, but probably when you are this was when I start with this transition, and when you have another things to do, probably you have not enough time to learn. So I I couldn't read the data and display like here. So I know that exists. I never use it, but I cannot say if it's good or not. So another way to read this MPAS data is the NCAR command language, or NCL. The problem with this was discontinued. By the way, NCAR migrate directly to Python, right? I think in 2019 they say our official scripting language now is Python, and NCL is still there, but probably is no more supported. And also, I know that there is different Python libraries that you can read directly this MPAS data into this ecosystem or environment, Python environment. Now I will focus specifically on Python. Mm, If you and now I will focus specifically on MPAS atmosphere, because this is basically what I'm using. Okay, because I know that MPAS also there is MPAS ocean and MPAS the ice and land ice, I think. So, but in the official website of MPAS atmosphere, uh, if you are going to this how to visualize, they recommend to use this MPAS plot, and they provide this GitHub repository. You can see probably it's this, and also I know that there exists another library. It's not specifically for MPAS, but you can read and plot the data is called UX array. But for me, as I mentioned before, this when I started, this was the tool that I knew and was not I mentioned was not enough for me. Okay, that's why I decided to start to work on my own way. So first, I need to mention I start to use MPAS on 2018 when I was working in my country. I'm from Mexico. I start to develop some code to run this MPAS model. And that time I remember here is an image that I saved from that time. For this, I'm not sure if you know Python, probably yes. Inside there is an function called try or tree plot. In this, you can select three different points and it plot like a square. But the problem on this is your MPAS data is not a triangular based, it's hexagonal based, right? So that's why, in my opinion, so it gives you a faster image and looks fine, but it's not accurate, in my opinion. Uh, After that, what I say, okay, what if I know the point of the centroid and I can use uh, these markers, hexagonal markers. And as you can see here in this, looks fine, looks really good. But the problem is, what happens if you now decide to create a zoom in? Now you need again to change the size of this icon, okay? And this take time to try to identify what is the right size for this icon. So and also this works really well like here if your mesh is quasi uniform. But what happen if your mesh is with variable resolution? Also you need to change the size of your marker according with the size increasing of your mesh, right? So no, that's not an option. Another idea what I had was, what if I can create polygons one by one and create like GeoJSON files? So it works. By the way, this image is one of the what I did in the past and works fine. But again, it takes time because you need to generate one by one, take the polygon, save, take the polygon, save. So is if the area is small, you can get faster, but if it's bigger, no, it is really slow. And finally, uh, another thing that I know many people is doing is, well, now let's try to rasterize in lat long basis and create a traditional mesh. But for me, particularly, I say, well, so what is the idea to rasterize in lat long if you have now this ability to create this increasing or decreasing resolution? So if it, again, if it's a quasi-uniform, it's fine. What happens if your mesh is this high resolution to coarse resolution? Which one is the best resolution to recreating the mesh? So it depends. So also is my thought, right? So based on all those limitations was when I start to identify a couple of advantage of use specific, mm, probably not well used commands or functions in Python, NumPy, Matplotlib to generate our own way to plot this data. So here again is this mesh that I mentioned and I showed you before, and this is New York metropolitan area, 1 kilometer in the middle. This is the transition. and this one, the outer is 9 kilometers. So what we did basically was instead of generate polygon by polygon the mesh, we generate the entire mesh, like restructuring the configuration of um, the vertices of the polygons. And we are tested this not only with our own mesh, also we did with different meshes that we can download from MPAS-Atmosphere website. These six, this A, B, C, D, E, and F, and other. This is regional mesh and also works fine. And this last is from the weather company. The graph model is the name. So here, all those are quasi-uniform, and all those are variable resolution. And our methodology works really fine. Another thing is we were able to use different projections using Cartopy, and the polygons are not distortionated, and all of those, as you can see, are working really well. Here we are using a coarse mesh, but also it helps to look how well you can see here the polygons, right? And there is no distortion more than the projection itself. Also, what we did was to compare our MPAS-Viewer with the other two tools. So also I need to mention this graph is showing only the visualization part, how fast was to visualize. I'm not evaluating the tools itself, okay? In all those cases, our methodology was fast to visualize this unstructured mesh. This was the characteristics of the machine that we used. Basically, we are working on Debian in a workstation. And here are a couple of examples of our own mesh. As you can see here, another thing is we decide to create specific color maps according with each variable, static variables and output variables. So here, the terrain, the news, the mask, and here is the radar reflectivity, um, total outgoing atmosphere long wave, the precipitation and temperature. So as you can see here, the maps looks really acceptable. Now here, the idea is to show how looks like in a zoom in areas. And let's focus in the top. This is precipitation. The red line here, I'm trying to show how is the transition between the 9 kilometers to 1 kilometer, and there is no distortions. You can see also um, the shape of the cells mesh, hexagonal. And here, if you in the middle, where is the dense mesh, also you can see that there is no kind of distortion, and you can see perfectly like how is grouped based on the colors. And for the reflectivity, similar. Another thing that I did was start to request for people that I know that they are using uh, MPAS. One of them was in this NSSL, the WOFs, Work on Forecast System. I request couple of data to test my code, right? So now here you can see the code works fine. Um, and also I download this map data. This map means the Mesoamerican affinity group and also works really fine. But also because I know that there is another course from MPAS. I test my code with ocean data, and also I adapt a color bar for this to look nice. And you can see it is working well. And finally, related with this data, I request for I know that someone at NOAA, they are working with this transition to MPAS chain, and they provide me an example. And here, as you can see, also it works really well. So now is tested my code with different data, different cores, and here is an example how it works. The most basic part. Is to identify the cell ID number, and based on cell ID number, you can get directly this time series. And that time series are, in our case, something that was really necessary for our comparison with weather stations. Now here is to show how was this data with local NetCDF. For that, what I did, I download this map data, and well, you can see here in the example. I cropped the data to get a fast visualization. I create this widget, the slider, to modify based on weather variables and times. As you can see, it's really fast the plot, but uh, but not only works with local data. As I mentioned before, I tested at the beginning with with the graph data. Graph means global high resolution atmospheric forecasting is data from the weather company. They provided by um, Amazon Web Service the open data. And here is the example how it works with SAR remote data. Something that particularly for me is interesting is, as you can see here, the change of the plot is relatively fast, right? And consider that the data is not in your local machine, is in these buckets on AWS. Finally, finally related with these videos, I tried to create some more interactive. For now, it is working well, but this, well, for me, is not enough. I'm using this Bohik or Bohik. I'm not sure what is the right pronunciation in Python. And the problem with this is to develop this kind of maps. And because it's JavaScript based, the data needs to be in the memory, and it is heavy, in my opinion. For now, it works fine because the domain is relatively small, but probably it is not the best if the data is a huge data. Uh, this is how it looks for another course. I showed it before with MPAS Ocean, but here is with this I don't remember the name of this kind of projection. As you can see, also works really fine. And yes, finally, this is my last slide. Um, we create an efficient code to provide a fast access to this unstructured MPAS mesh. Also, if you need a lat long extract based on lat long point, you can get the cell ID, and based on cell ID, you can get directly and pass this time series. The plotting part was optimized, so you not need to do this slow loop to generate the mesh, and we can generate these time-based animations. We are exploring more options like the interactive map. And we are continue working on ocean on sea ice uh, to increase the capabilities of this tool. And also what we published this tool is already published on this software X journal. This is the QR code. This is the name. And also you can see directly, you can get directly here the code in this GitHub repository. And well, this is all on my side. Thank you so much for this opportunity.
Awesome. Thank you so much. Do we have any questions? I don't see any comments or anything, but we've got plenty of time for any questions.
Yeah, sure.
So I've got a comment for you. Um, what was it like developing with those hexagonal grids and finding some of those discrepancies? Because I know MPAS has really come a long way in the last few years, but I was wondering how you were able to find any sort of quality improvement in terms of the way that you plotted versus the way that you interpolated, and if you were able to figure out what was making some of those things slower um, in some of those regridding. It's a big question, but
Yeah, I know. So, as I mentioned, I started to work with this MPAS years ago. So my focus never was to create this kind of tools, but I was involving, and I know that the most common way or the unique way that to plot the MPAS data was to generate this mesh based on a for loop, create polygon by polygon. But after that, I found how you can restructure uh, the nodes of each polygon in in a structure, and you can fill just basically with the nans, okay, at the end. So and then you can get a structure. And yes, the problem is probably I'm not the best to try to explain how this is, but you can get a structure of flat and longs, and when you send directly to plot as a mesh, it Python NumPy can interpret it, because at the end of the day, the last values are nonce, and it only connect where is the values. I'm not sure how to explain this, but
yeah, kind of that serial iteration of it. Yeah, but I think sometimes for some of the interpolation operations, it's kind of how it works. And um, I know that X-ray has all sorts of parallelization. Do you know if
uh,
any of that's leveraged in the?
no, I know that I need to improve my own code. So to this parallelization part, to try to add another features to, but mm, yes, for now is yeah. Sorry. um,
Yeah, no, and that's one of the best parts about those open source tools. So yeah. Also, my apologies if there was a lot of background noise right now. on my side.
No, don't worry, it's fine.
Okay, well, if we don't have any more questions, I think we'll go ahead and stop the recording right here.